Did you know there are 11 different types of addition and subtraction problems? Recently I went through some year 3 maths problems, and actually very few of these were actually there. There were lots and lots of the first one I'm going to show you, and 1 or 2 examples of any of the others, and some of them weren't even there at all. So it's really important that students can tackle these problems and that we actually consciously go through and present and teach these problems. So let's take a look. So at the top of the page, you'll see on the left hand side I've written the type of problem, and that's on the top of all of these slides. So this one, we're joining things together, but the result is unknown. This is the most common one that we see. Tracy had 25 biscuits, Georgie gave her 10 more. How many biscuits does Tracy have altogether? Well, Tracy had 25, she added on 10, and Tracy had 35 altogether. That's the most common way we present problems. However, we could go, Tracy had 32 biscuits. How many biscuits does she need to have 40 biscuits altogether? So we know I've got 32. Oops. We're going to add on some more that we don't know, and we know that we're going to have 40 here. So the change is unknown. We know it's 32 plus something equals 40. And children can solve this in a number of ways. They may count on and they may count back. But it's important that they know that that's what they need to do. In this one, the start is unknown. Tracy had some biscuits. We don't know how many biscuits I had. Georgie gave her 10 more, and now I've got 13. So how many did I have to start with? So I had some biscuits, and then I had 10 more, and I ended up with 13. And again, children could go about working this out in a number of different ways, but they need to know that that's the number they're looking for, which obviously in this case is 3. So the next type of problems are all about separating things. So Tracy had 12 biscuits. She gave 8 to Georgie. How many biscuits does Tracy have left? This is the very common way that things are presented. I had 12, I take away 8, and I'm left with 4 biscuits. Really simple. In this one, Tracy had 28 biscuits, so the change here is unknown. We're still separating. So I've got 28. I'm going to give some to Georgie. Now, sum is a number, and for some of my students, knowing that sum is the missing number or the number they're looking for, or a number, is really useful to know. So she had 28. She gave some to Georgie. There's my sum. And now she's got 25. How many did she give to Georgie? So you could count back, you could count forwards from 25, and you could solve that to find out the answer is 3. This time separating, but this time the start number is unknown. I had some Tim Tams. I gave 10 to Georgie, and now she's got 4 left. So Tracy had some Tim Tams. We don't know. She gave 10 to Georgie, and she's got 4 left. So how many did I have to start with? So I would have had 14 to take away 10. And some students will know that the 4 and the 10 will go together and make up the 14, and others will solve it in different ways. Tracy had, so this one is part whole. This is very similar to the joining. However, we're joining like one whole group together, looking at the 2 different parts of a group rather than some apples and some more apples. So this one is all about gems. So this one is 15 blue gems, 5 red gems. How many now in this whole set? So we know that there's 15 and there's 5, and in the whole set then that would make that there's 20. It is very similar, it's just a nuance, very simple in the syntax. In this one, part whole again, but the parts are unknown. So I've got 24 gems, 4 are red and the rest are blue. How many are blue? So I've got to do, I know I've got 24 altogether, and that's made up of 4 and a number I don't know, which will be 20. But how could you go about solving that? I could do 24 and take away 4, and that would give me the answer. I could do 4 plus something equals 24. There is always more than one way to solve the equation. And in this one, we're now comparing things, looking for the difference, but the difference is unknown. Now this is tricky for some children, and I often teach this by getting them to lay them out. So Georgie's got 16 flowers, so I get Georgie to draw 16 flowers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. I usually try and group them to make it easier. Tracy's got 14, 8, 10. I've got 14. How many more does Georgie have than Tracy? You can see there when we compare them that I've got 2 more. You could do this as 16 take away 14 equals 2, but children need to be able to see that this is comparing who's got more and how many more. And again, comparing again, Tracy's got 18 flowers, Georgie's got 10 more than me. So I've got 18 and Georgie's got 10 more. So I could do 18 plus 10. Or I could draw the 18 the same for both of us in a similar way to this, and then see the 10 more as well. And the last one is comparing where we don't actually know what we're starting with. So Georgie's got 16 flowers. She's got 4 more than me, more than Tracy. How many flowers does Tracy have? So if Georgie's got 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 1 more. She has 4 more than Tracy. So she's going to have 4 more than me. She's going to have this one, and this one, and this one more than me. So this is how many I will have. Which if you lay it out in the 5s and in groups of 5, that makes it easy to see that that's 12. So there are lots of different ways you can do that. I've written a blog post about this that you can find on my website, tracyashbridge.com. I hope this has been helpful. Next week I'm going to do multiplication.